Now we perform an experiment to determine the dielectric constant of the material. Dielectrics are basically insulators and do not conduct electricity at all because they have no free electrons. But when a dielectric is placed in an electric field, it has a profound effect on the electric field strength. When a dielectric is placed in an electric field, it results in the formation of the dipoles. A dipole is nothing but a pair of equal and opposite charges separated by a small distance. These dipoles get aligned in a particular direction such that there is a layer of positive charges on one side and there is a layer of negative charges on the other side, which results in the formation of an electric field within the dielectric. This direction of the electric field will be in a direction opposite to the direction of the applied electric field. Therefore, there is a reduction in the electric field strength, which means there is a reduction in the potential across the dielectric. So, when there is a reduction in the potential, it enhances the capacitance of the capacitor between which plates the dielectric is placed. Now, we have to determine the dielectric constant of the material of the dielectric which is placed between the plates of the capacitor. We should understand what a dielectric constant is. Dielectric constant in fact reduces the electric field strength if its value is more. So, greater the value of the dielectric constant, greater will be the reduction in the electric field strength. Dielectric constant is defined as the ratio of the capacitance of the capacitor with the medium as the dielectric to the capacitance of the capacitor with air as the dielectric. It can also be defined as the ratio of absolute permittivity of the medium to the absolute permittivity of free space. Alternatively, it can also be defined as the ratio of force between two charges separated by a certain distance in air medium to the force between the same two charges separated by the same distance in any other medium. To determine the dielectric constant, we build up the circuit as follows. We connect the power supply to the main circuit and then we close the gap between G and H and we drop connection of the resistance of 220 kilo ohm to the circuit. Then we connect the electrolytic capacitor such that the negative of the electrolytic capacitor is connected to the negative and the positive is connected to the positive. Then we drop connection from voltmeter such that the negative of the voltmeter is connected to the negative and positive is connected to the positive. So, this is a complete circuit that has been built up. Before we switch on the circuit, we have to take care to see that the toggle switch here is directed towards the discharge mode and then the timer switch is towards the stop mode. Then we switch on the circuit and we have to see that the readings on the display screens will be 0 on either side. If it is not, then we can discharge the capacitance, the potential across the capacitance by touching these two cables. So, once this is done, we have to be ready to record the readings so that while the capacitor is getting charged, we record the readings every 10 seconds. So, we switch on, so the timer runs and every 10 seconds the reading of the voltmeter is recorded. So, 10 seconds we record and when it comes to 20th second, once again we record the reading of the voltmeter, 30 seconds we record the reading, 40 seconds, like that we have to go on till the voltage reading across the capacitor gets almost saturated. It happens at a time when it is about 120 seconds. One should be very observant while recording the readings because the timer keeps running very fast. So, you need to record it very carefully. So, you will see that when the time is progressing, the voltage value across the capacitor has almost got saturated. It is rising very slowly now. It has almost become constant. When once this has happened, we have to shift the toggle switch, the timer switch towards halt mode, reset the timer button so that the timer reads 0 now, and gently slide the two toggle switches towards discharge and start mode simultaneously. Now we are recording the readings while the capacitor is getting discharged, and the recordings will have to happen every 10 seconds. Once again, one has to be very observant and keen while taking readings because the timer is running very fast, and every 10 seconds you have to keep recording the voltmeter readings. So, you are noticing that as the timer is running briskly, the voltmeter reading is very slowly changing now. It's almost becoming saturated. Now we are done with the experimental part of the experiment, and then we have to now calculate the dielectric constant by plotting the graph of voltmeter readings along the y-axis and the time along the x-axis as shown in the graph. So, here we see that the voltmeter readings are on the y-axis and the time along the x-axis. We have two exponential curves which intersect at a particular point, which we call as half time. Half time is nothing but the time during which the quantity of charge on the capacitance gets reduced by half its initial quantity. So, this is to be noted down from the graph, and then we substitute that value in this formula. 10 power epsilon r equals 10 power minus 6 T half d divided by 0.693 r epsilon naught a, where the symbols have the following meaning, that is T half is the half time, d is the distance between the capacitor plates, r is the resistance that we have used, that is 220 kilo ohm, epsilon naught is absolute permittivity of free space whose value is 8.54 into 10 power minus 12 farad per meter. Area A is the area of the capacitor plate. So, this is how we determine the dielectric constant of the material enclosed between the plates of the capacitor. One could also perform the experiment by using a different capacitor such as C2. So, as a second trial, you could also perform experiment using the capacitor C2. and the same procedure is repeated all over again. Dielectric constant measurement helps us in a way that we can fix the value of the capacitance of the capacitor, which has a practical application in various sectors.